This is how you would load programs into this oversized communist calculator made in the year of 1982 in Czechoslovakia. Although this board is a modern-day replica, except for the keypad and these bus connectors, the rest of the components are relatively period correct. This was originally conceived as a teaching tool for use in secondary schools. It is based on an Intel 8080 counterfeit, just as everything else in that time period. These are the jumpers for the CPU to support external interrupts. This is the system bus connector. This is the RAM. It contains 2 kilobytes and just 1 kilobyte of RAM here. One 8255 PPI is used to address the keypad and to address the display. The second one is populated, but it's currently unused. This is its bus connector right here. Over here we have a small breadboard section. On the left there's a small experiment to try and make this talk to a PC via an old-fashioned serial port, and this is a small amplifier circuit designed to help with the tape recorder input, because straight from the factory this required over 20 volts peak-to-peak signal, which most of these shoebox recorders won't even get near such a value, so this is to increase the sensitivity. Over here we have a very old-fashioned LED display, and this keypad was originally a piece that came from an old calculator. These micro switches are of course new. Before I start, I will need to turn the desk lamp off because this display is very dim, as you'll see in a moment. After the power has been applied, a welcome message should appear, PMI-80, which we can now dismiss, and now the board is ready to accept commands. The only mode of operation here is to insert individual instructions as machine code, as bytes, into memory locations. The other options are to set breakpoint on a memory offset, to dump the registers, to wait for an external interrupt, to reset the machine. The reset button does not alter the memory contents unless I do a power cycle, and then we can dump the memory to tape or load it from tape, which we'll try currently. We need to specify the starting offset. In our case it's going to be 1C00, and now we need to specify the record number, which we only use 00 here. Now we need to start the tape recorder, and the data is now loaded in 256 byte chunks. There's no error correction or checksums being verified, so if there's any problem with the levels, it will just fail. Now we load the code. The first chunk is done. So now the data, a text string, which we'll do again to offset 1D00, which is 256 bytes right afterwards. That's record number 00 again. And we're done. The moment of truth is to execute the memory allocation we have just loaded from tape, so 1C00. And we get a mark U text. Let's insert this to increase the brightness a little bit. What a machine. Another way of getting data into this thing is to use the improvised serial interface. This makes use of the two unused lines in the 8255 PPI here and some custom loader routine in the second EEPROM. Needless to say, I'm not the original author of the code found in the EEPROMs. Now the two data lines in question, PB0 and PB1, are connected to the serial ports DTR and RTS lines through two small signal switching transistors. Now the first line, the first bit, is used to load a shift register, and the second bit is used for synchronization purposes, to mark if the bit has been processed and if the next bit is ready. Knowing this, a simple Python script can then be devised to load a file and send it over these two lines. The file can be either binary or an Intel hex. There's not a lot of games that can be played on a 7-segment display on something which is clocked at 1 MHz, but here's one. To get into the loader, we need to execute a certain memory location, which is at offset 400, That's the starting offset right after the first kilobyte. So the loader will load the contents at memory location 1C00, which is the start of the RAM in this thing. So this is now ready, and we can start the actual transfer. This will take only a couple of seconds because it's just a couple of bytes. Now we can execute the contents of the RAM, so that's offset 1C00. Cosmos, a very simplified version of the Space Invaders. So the dash on the left needs to avoid being hit by the objects coming from the right. Game over. Now we can have a look at the hex dump of this game, so that's Command M, offset 1C00. These are the individual instructions that we can also change.